No, that was right. Okay. A is your initial value. Your R is going to represent your rate. Your rate is going to be percent over 100. So you're going to automatically give in a percentage, automatically divided by 100 to turn it into a decimal. T represents time. Your time will also be represented with X. So if it's talking about years or hours, most likely that is going to be your X value. Now, when we solve it, that's when we get our Y answer. Your Y is your new value or new amount after time has passed. Okay, so after we've gone the year or whatever, and so when we're looking specifically right now at exponential growth, we need to know that B is going to be over 1. So my growth factor, which is going to represent my B, is 1 plus my rate. So when we're looking at the problem, your B is broken down and separated to 1 in the rate. So if I were to give you the B, you should be able to tell me what the rate would have been. So my example, the original value of a painting is $9,000. So because that's the original value, that is my A, 9,000. The value appreciates. The word appreciates represents growth. By 7%. When you have a percent, that is your rate. So 7 over 100. Y'all, I don't know why for A I wrote 9,009, but 9,000. So we need to know what our function is. My equation is going to be Y equals 9,000. 1 plus, the plus is representing the growth, 0.07. Where did I get 0.07 from? Dividing 7 by 100, that is the rate. So you can also just go ahead and calculate your growth factor. The way I do it is I just go ahead and combine those. So remember your growth factor, which is going to represent what B is. Oops, wrong color. It's going to be 1 plus 0.07, what equals 1.07. So I would have originally written the equation as Y equals 9,000, 1.07 to the X power. Now we're looking and we say that the painting's value, we're looking for the value in 15 years. That means your X, which is time, is going to be 15. So in our calculator, we're going to put 9,000, 1.07 to the power of 15. And that's going to give me 24,831.28. So again, that was specifically exponential growth. Turn the page. We're going to now look at an exponential decay. So again, our values are all the same. A is your initial value. Your R is rate. T is time, which also represents as X. Y is your new value after time. But our our decay factor, again, is going to be represent B. Because it is less than 1, we need to understand that it's going to be 1 minus your rate. So that's going to be the difference. And y'all are very much already used to saying if it's growth or decay. You just need to make sure you understand it's subtracting 1 and adding 1. So our example is the population of the town is decreasing. Decreasing is representing decay. At a rate, it's actually saying the word rate this time, of 3%. So we're taking 3 over 100. In the year 2000, there was 1,700 people. So my A is 1,700. My equation is Y equals 1,700. 1 minus 0.03 to the X power. I can go ahead and find my my decay factor, and take 1 minus 0.03. That equals 0.97. So I can write my equation as Y equals 1,700 times 0.97 to the X power. And 1 minus 0.03. Where did the 0.03 come from? The rate divided by 100. So when I just went ahead and subtracted it and got 0.97. So now this is where a lot of people are going to mess up, figuring out what your time is. A lot of you guys are going to say time is 2012. It is not 2012.
12.
How do you know it's 12?
Because I subtracted 2000.
Thank you. That is awesome. That is exactly right, but a lot of people would not have done that. So you take 2012, subtract it from 2000 to get your 12. So my X is 12. So 1,700, 0.97 raised to the 12th power. That's going to be 1,180 people.